Hello friends, I am Kishore Vittalkare working as Assistant Professor of Chemistry in Ray Shikshan Samsthas, Professor Dr. N.D. Patil Mahavidyalay Malkapur, Taluka Shevwadi, District Kolhapur. Today we will discuss Organic Chemistry, paper number 2nd, semester 1st. This video is for educational purpose only. No copyright belongs to its rightful owner. Credit goes to respective video music composer and singer. In this paper there are total 4 units. Out of these 4 units we will discuss first fundamental of organic chemistry, then introduction. Advancing and exploiting of organic chemistry demands a clear understanding of molecular reactivity, but chemical reactivity is related to molecular structure. So, establishing a concrete correlation between structure and function is a matter of great interest and challenge for research. First point of this topic, curve arrow notation. A chemical reaction essentially involves redistribution of shared or lone pair of electron between the reactant or within a substrate molecule. This causes breaking of some existing bond and making of some new bond between chosen atomic pairs to give the products. The movement of electron within a substrate or between reactant during a reaction is shown by shorthand notation of curly or curved arrow. There are two types of curved arrow. First, double headed curved arrow, and second one, half headed curved arrow. First, double headed curved arrow. The movement of pair of electron is shown by double headed curved arrow. Double headed curved arrow. It is indicated by this letter, double headed curved arrow. So it is useful to show ionic mechanism where heterolytic bond fusion occur. For example, OH minus. For example, this OH minus react with methyl bromide, which gives methanol plus Br minus. That is reagent OH minus react with subtract methyl bromide, which gives methanol product. It is represented by this double headed curve arrow. Then second point, second type, half headed curve arrow. It is denoted by this half headed curve arrow. The movement of single electron is indicated with a half headed curve arrow. They are single barbed fish hooks. In homolytic cleavage, the movement of single electron takes place leading to the formation of free radical. So it is useful in representing free radical mechanism. For example, methyl bromide undergo homolytic cleavage gives methyl radical plus bromine radical. That is, in methyl bromide there is homolytic cleavage. That is, there are two radicals formed. First one is CH3 radical and second one is Br radical. It is indicated by this half arrow letter. The next second point of this unit, cleavage of bond. Essentially a chemical reaction involves bond breaking and bond making. The cleavage or breaking of chemical bond of chemical species to form two fragment species is called as bond fusion or cleavage of bond. Two mode of bond fusion are under. First one is homolysis, or it is also called as homolytic fusion, and second one is heterolytic fusion. It is also called as heterolysis. Then let us first discuss homolysis or homolytic fusion. The symmetric or even breaking of covalent bond to form a pair of free radical is called as homolysis or homolytic fission. Example of this homolytic fission is cleavage of CBr bond in methyl bromide occurs by homolysis. For example, methyl bromide undergo homolytic cleavage to form this methyl radical and bromine radical. Homolytic bond fissure normally occurs in gaseous phase or in heat or UV light and peroxide catalyst. Organic reactions which proceed by homolytic fission are called as free radical or non-polar reaction. Then second, heterolytic fission, or it is also called as heterolysis. The unsymmetric or uneven breaking of covalent bond to form a pair of oppositely charged ion is called as heterolytic fission. It is shown by double-headed curved arrow as a pair of electron move to only one of the atom. Heterolytic bond fissure normally occur in solution phase. On heating, polar solvent promote heterolytic fission. For example, heterolytic cleavage of bromomethane and that of acetone. That is first example for bromomethane, that is methyl bromide. Methyl bromide undergo heterolytic fission, which gives these two ions, that is bromide ion and methyl carbocation, that is methyl cation. In heterolytic fission, the more electronegative atom takes away both the shared electrons with it. So it will have completed valence octet with at least one lone pair and negative charge. While the more electropositive atom has a sextet electronic structure and have a positive charge. That is, this CH3 plus ion have a, that is carbon in this carbocation central carbon atom have sextet electronic structure, so it acts as positive charge, and this more electronegative Br acts as negative charge. Then third point of this topic, organic molecular species. In a chemical reaction, the molecule that transfer into different chemical species is called as substrate. The new molecule formed is called as product. Quite often an attaching molecule called as reagent is used to effect this transformation. Commonly substrate and reagent are together called as reactant. That is, substrate plus reactant gives product. Depending on the site of attack on substrate, two types of reagent are recognized. First one, nucleophile. It is also called as nucleophilic reagent. And second one, electrophile. It is also called as electrophilic reagent. Let us first we discuss nucleophile. An electron-rich species which attack an area of low electron density, that is positive center in the substrate, is called as nucleophile. They donate a lone pair electron to an acceptor to form a covalent bond and act as Levy's base. They can be of two types. First one, negative nucleophile. It is also called as anionic nucleophile. Any negatively charged ion that carries a lone pair of electron on its central atom acts as nucleophile. It is represented as Nu minus. They attack positively charged substrate to form neutral molecule. For example, OH minus, Cl minus, Cl minus, I minus, NH2 minus, etc. are the example of negative nucleophile or anionic nucleophile. Then neutral nucleophile, it is denoted by Nu. Any neutral molecule having a lone pair electron on its central atom act as nucleophile and represented as Nu. They attack on positively charged substrate to form positively charged species. For example, H2O, ROH, RNH2, NH3, it is here the example of neutral nucleophile. The reaction which involve nucleophilic attack are called as nucleophilic reaction. Then electrophile, it is also called as electrophilic reagent. An electron deficient species which acts an area of high electron density, that is negative center, on subtract is called as electrophile, and it is denoted as capital E letter. It acts as Lewis acid by accepting a pair of electron from donor to form covalent bond. They can be of two types. First one is positive electrophile, it is also called as cationic electrophile, and second neutral electrophile, it is denoted by capital E letter. Then first positive electrophile, it is denoted by E plus or cationic electrophile. Any positively charged ions act as positive electrophile and represented as E plus. It attacks an electron rich center on subtract, forming a neutral molecule. For example, H plus, Br plus, Cl plus, H3O plus, NH2 4 plus. It is here the example of positive electrophile. Then second, neutral electrophile. It is indicated by capital E letter. Any neutral molecule whose central atom has incomplete octet act as neutral electrophile and represented as capital E letter. They attack on positively charged subtract to form negatively charged species. For example, BF3, AlCl3, ApCl3 are the example of neutral electrophile. The reactions which involve electrophile attack are called as electrophilic reaction. This video is for educational purpose only. No copyright belongs to its rightful owner. Credit goes to respective video music composer and singer. Thank you.